Hello students, welcome to another session of inverse trigonometric functions. In this session, we are dealing with few more properties on inverse trigonometric functions. So these are the three relations or properties that you are going to study. See here, first one, 2 tan inverse x is equals to sine inverse of 2x by 1 plus x square. And even 2 tan inverse x can also be equals to tan inverse of 2x by 1 minus x square, and 2 tan inverse x can also be equals to cos inverse of 1 minus x square by 1 plus x square. So remember that 2 tan inverse can be expressed in three ways, that is in terms of sine inverse, in terms of tan inverse, in terms of cos inverse. Okay, so let us prove this. So here is the first one. You are supposed to prove that 2 tan inverse x equals to sine inverse of 2x by 1 plus x square. Okay, very easily it can be proved by taking RHS. Okay, so consider RHS. So I will consider this RHS. So write down RHS is equals to, consider RHS, right hand side. Okay. Now we make substitution. Put x equals to tan theta. Why tan theta? I will tell you. Okay. So put x is equals to tan theta. That is theta is equals to tan inverse x. Now what it becomes? Right hand side becomes, it is sine inverse of, it is 2 tan theta divided by 1 plus tan square theta. So this is your right hand side. Okay. Now as we all know, 2 tan theta, this one bracket term, 2 tan theta by 1 plus tan square theta is equals to sine 2 theta. You must know this. Sine 2 theta is nothing but 2 tan theta by 1 plus tan square theta. This is one of the identity that you have studied in first PUC. Now you can write sine inverse of sine 2 theta as 2 theta. Okay, sine inverse and sine get vanish. Okay. Now you can replace your theta 2 as it is. Theta is your tan inverse x. Okay. So this is your result. So you can write, therefore 2 tan inverse x is equals to sine inverse of 2x by 1 plus x square. Okay, so you have to remember this. Sometimes we use this. Okay, so similarly we will have second one. So here is that 2 tan inverse x equals to tan inverse of 2x by 1 minus x square. Okay, so it can be proved in two ways, considering right hand side, that is tan inverse x plus tan inverse x. Otherwise we follow the common method. Okay, so consider right hand side. So consider this RHS, consider this RHS and make same substitution. Put x is equals to tan theta in all the cases. Okay, because here 2 tan theta by 1 minus tan square becomes tan 2 theta. That is the reason you are substituting this. So this implies theta is equals to tan inverse x. Okay. So therefore your RHS becomes tan inverse of 2 tan theta by 1 minus tan square theta. Okay. Now tell me or remember the trigonometric identity. This 2 tan theta by 1 minus tan square theta is tan 2 theta. Okay. If this is plus, you will get sin 2 theta. Okay. Now tan inverse of tan get vanish. You left with 2 theta and 2 into theta means tan inverse x. Okay. So write your conclusion. Therefore 2 tan inverse x can be equal to tan inverse of 2x by 1 minus x square. Okay, very easily you can prove this. Similarly, same substitution for the third type. Look at this. 2 tan inverse of x equals to cos inverse of 1 minus x square by 1 plus x square. Okay. So as usual, pause the video and proceed. Consider RHS. Okay. If you are confident, then pause the video, just do yourself. Same substitution. Put x is equals to tan theta. That means theta is equals to tan inverse x. Okay. So this becomes cos inverse of 1 minus tan square theta by 1 plus tan square theta. Okay. So now look at this. 1 minus tan square theta by 1 plus tan square theta is a cos 2 theta. Remember this. And which is equals to cos inverse of cos 2 theta. You will have 2 theta just, and you can replace your theta. Theta is your tan inverse x. Okay. So thus 2 tan inverse x can be expressed in terms of cos inverse, that is cos inverse of 2x by 1 plus x square. Okay, so very easily you can prove these results, and even they are important too. So please work out these 3 properties and as well remember. So let's have one example, this one. Okay, so show that sine inverse of 2x into under root 1 minus x square is 2 cos inverse x. Okay, you are supposed to show that sine inverse of 2x by square root of 1 minus x square is 2 cos inverse x, provided x belongs to this interval. Okay, so let's prove this. So consider LHS. Consider LHS is equals to sine inverse of 2x into root of 1 minus x square. Okay. Now substitute. put x is equals to cos theta. Okay, so I told you whenever you will have 1 minus x square form, either you have to bring in your mind 1 minus sine square or 1 minus cos square. Okay, so if I substitute x is equals to cos theta, look what will happen. This means theta is equals to cos inverse x. Okay, so what we will get? Sine inverse of 2 into cos theta, because x is cos theta, under root 1 minus x square means cos square theta. Okay, which is equals to sine inverse of 2 cos theta under root 1 minus cos square means sine square theta. Okay, so which is equals to sine inverse of, this is 2 cos theta into square root of sine square theta is sine theta. Which is equals to sine inverse of, and as we know that 2 sine theta cos theta is sine 2 theta. So this you have to write sine 2 theta. Okay, so better you note down this, because sine 2 theta is 2 sine theta cos theta. Okay, so now sine inverse of sine get vanish, you left with 2 theta, and what theta you are substituted? Theta is your cos inverse x. Okay, so this is your required RHS. Okay, look at this. Same result we have next. Here it is sine inverse x. In that case, you have to put x is equal to sine theta. Okay, so please do remember this. Once it was asked to prove. Yes. Similarly, this. Show that sine inverse of 2x into square root of 1 minus x square is equal to 2 sine inverse x, provided x is this much. Okay, so not to worry about this, it will be provided by the question setter. Okay, so consider LHS equals to sine inverse of 2x into root of 1 minus x square. Okay, so now substitute. Now in this case you put x is equal to sine theta. Okay, so theta is equal to sine inverse x. So what we will get? Sine inverse of 2x. 2x means 2 sine theta into square root of 1 minus sine square theta. Okay, this is equals to sine inverse of 2 sine theta and square root of 1 minus sine square means cos square theta. Okay, so rest of the thing is as usual, as earlier you have done. It is 2 sine theta and square root of cos square is cos theta. Okay, so which is sine inverse of this 2 sine theta cos theta is sine 2 theta, as I mentioned earlier. Okay, now you will left with sine inverse sine gets vanish, 2 theta you left. Now replace your theta. So 2 into theta is sine inverse x. So how simple it is. Okay. So please work out this. You may expect in the exam too. Okay. So here is one more thing you need to prove this. Prove that tan inverse of x plus tan inverse of 2x by 1 minus x square is equals to tan inverse of 3x minus x cube by 1 minus 3x square. Okay, so remember this. Okay, so consider RHS. Taking RHS, you can prove it very easily. So consider this RHS. Okay. Now see here, 3x minus x cube by 1 minus 3x square. You remember this tan 3 theta formula. Tan 3 theta is 3 tan theta minus tan cube theta divided by 1 minus 3 tan square theta. You remember this tan 3 theta formula. Okay, so here look at the inside function, that is it is in the form 3x minus x cube by 1 minus 3x square, that is 3 tan theta minus tan cube by 1 minus 3 tan square. So that is the reason we substitute. Put x is equals to tan theta, which gives you theta is equals to tan inverse x. Okay, now see here what RHS becomes. Your RHS becomes tan inverse of, okay, so this 3 tan theta minus tan cube theta divided by 1 minus 3 tan square theta. Okay. Now tell me what this inside term turns to. It becomes tan of 3 theta. Tan of 3 theta. Okay. Now see here. Tan inverse tan get vanish. You left with 3 theta. Okay. Now theta is what? Your theta is tan inverse x. Okay. Now interesting thing is this 3 tan inverse you split it as tan inverse x plus 2 tan inverse x. Okay. So this 3 tan inverse x, you write it as 1 tan inverse x plus 2 tan inverse x. And look how interesting it is. This tan inverse x as it is, and 2 tan inverse x we proved earlier, very first. Okay, 2 tan inverse x is equals to tan inverse of 2x by 1 minus x square. So this is your left hand side. Okay, because you proved this. 2 tan inverse is tan inverse of 2x by 1 minus x square. So your result is proved. So let's have what is next. This is maybe asked for multiple choice. Find the value of cos of sec inverse x plus cosec inverse x. Very simple. This is equals to cos of, and as we know, sec inverse plus cosec inverse x is pi by 2. This is one of the property that we proved. Okay, so sec inverse x plus cosec inverse x is pi by 2 and cos pi by 2 is 0. So very simply you can obtain this result if you know the properties. Okay, so from the point of CET also it is important. So let's have one more, this. Simplify. You are asked to simplify this. Okay. So divide both numerator and denominator by b cos x. Okay, so you have to remember this. Means whatever this, you have to divide both numerator and denominator by this quantity. See here what you will get. So your given reduces to this tan inverse as it is. One can write directly a cos x by b cos x minus b sin x by b cos x whole divided by b cos x by b cos x plus a sin x by b cos x. Okay, which is equals to tan inverse of, okay, in the first term this cos cancels, here b cancels, here full b cos x cancels. So what left? A by b minus sin x by cos x means tan x divided by, it is 1 plus a by b into tan x. Okay. Now here onwards it is interesting. You have to recall the property. Okay, you have to recall this. Note this. Tan inverse of x minus y by 1 plus xy is, this is your tan inverse x minus tan inverse y. Remember the property. Tan inverse of x minus y is 1 plus x minus y by 1 plus xy is tan inverse x minus tan inverse y. Okay. So similarly it resembles that. This is of the form tan inverse of x minus y divided by 1 plus xy. So here x is this and y is this. Okay. So I can write it as tan inverse of a by b minus tan inverse of y. Y is nothing but this tan x. Look at this. Okay. So this is of the form tan inverse of x minus y by 1 plus xy. So this is your x, this is your y. So which can be written as, this is tan inverse of a by b minus tan inverse of tan is get vanished, you will get x. So this is your result. Okay, so remember this as well. So this is enough in this session, and we will be meeting in the next session with exercise 2.2. So till then, take care.